All right, guys, we're going to go over the review sheet. So we're looking at problems 1 and 2 first. Now, the first one here, 2 to the 2x plus 15 is equal to 8 to the x minus 7. Now, for these here, we need the bases to be the same. Now, 2 is as simplified as it gets. We can't reduce it any further. So that means we need to get both of them to have a base of 2. So we need to rewrite 2, or 8, as 2 to a power. 2 to what power would be 8? So we can check and see. So we can... That out. Because 2 to the fourth is 16. 2 to the third would be 8. So for us here, it would be 2 to the third. And again, we need the bases be the same so we can solve this. Now, before we can start doing anything or solving from here, we do need to distribute our powers, because our powers of powers multiply. So our 3 times x would be 3x. 3 times negative 7 would be negative 21. Questions on this so far? Now, the reason we want the bases to be the same is because if the bases are the same, the exponents have to be equal. So we can set the exponents equal to each other since the bases are the same. And now we just need to solve for the value of x. Now, the first thing we can do in solving for the value of x is we can subtract 2x. Because our 2x minus 2x will simplify out. 3x minus 2x is x, and we still have our minus 21. Now at this point here, we can add 21 to both sides, telling us x is equal to 36. And that's it. So the main thing for this here is getting the bases to be the same. Once we have them to be, once they are the same, we set the exponents equal to each other. Questions on this here? All right. We're going to look at the next one. 512 to the 5x minus 1 is equal to 1 over 8 to the negative 4 minus x. Now, it'd be nice if we could write both of these as 8 to a power. Now, 1 over 8, I can move the 8 from the bottom to the top. And if we do this, the bottom of the fraction to the top, the exponent goes from positive to negative. Now, 512 would be 8 to the third. So we can rewrite 512 as 8 to the third power to the 5x minus 1. At this point here, our powers of powers multiply. So here we can distribute the 3. 3 times our 5x would be 15x. 3 times our negative 1 would be negative 3. Now we're going to do the same thing with our other side. We're going to distribute the negative 1. Negative 1 times negative 4 is going to be 4. Negative 1 times negative x is plus x. Questions on how we got to this point here? Now, since the x or the bases are the same, the exponents have to be equal. 15x minus 3 is equal to 4 plus x. Now, at this point here, we just need to solve for the value of x. What can we do next? We can add 3 to both sides. And if we add 3 to both sides, we get that 15x is equal to x plus 7. Now we need to subtract x from both sides. Telling us that 14x is equal to 7. And last but not least, we're going to divide both sides by 14. Telling us x is equal to. Okay. Questions on this here? We're ready for the next one. The next one we have e to the 4x plus 7 is equal to e to the 6x minus 35. Well, even though the bases are both e, they are both the same. And since they are the same, the exponents have to be equal. So our 4x plus 7 is going to equal 6x minus 35. Now, since we don't have any quadratic term, our x squared terms, we can go on and solve for x. We can get x by itself. Now, the first thing we can do is add 35 to both sides. And if we add 35 to both sides, we get that 4x plus 42 is equal to 6x. The next thing we would do is subtract 4x from both sides, telling us that 42 is equal to 2x. And last but not least, we're going to divide both sides by 2, telling us x is equal to 21. Any questions on problems 1 through 3? Number 4 is a little bit different because we don't have our just bases be the same. We actually have addition, subtraction, and multiplication. So before we can solve anything or apply any of our base or log, we need to get the term with the variable and the exponent by itself. In this case, e to the x. So what's the first thing we can do to get e to the x by itself? We would add 7 to both sides, because our negative 7 plus 7 would cancel, giving us 2e to the x is equal to 12. Now again, our e to the x is not by itself, so we need to divide both sides by 2, telling us that e to the x is equal to 6. Now the e to the x is by itself. We do need to apply something to get the x out of the exponent, and what we would apply the natural log. As we apply a logarithm to get the variable out of the exponent, and specifically we're going to apply ln, because our natural log of e to the x is going to reduce to x is equal to the natural log of 6. Does the natural log of 6 give us a nice number? We can check and see. Natural log of 6 is not a nice number. The only time that we do get a nice number is if we're taking log or natural log of 1, or whenever the number inside the logarithm is the same as its base. If we have one of those two situations, it will reduce nicely. Otherwise, it's not. So our final answer is the natural log of 6. X equals the natural log of 6. Questions on this here? Let's look at number 5. Well, just like the previous one, e is not by itself. So the first thing we need to do to get it to be by itself is to what? Subtract 9 from both sides. And we subtract 9 from both sides, we'll get 6e to the 2x plus 1 is equal to 6. Next thing we'll do is divide both sides by 6 minus e to the 2x plus 1 is equal to 1. Questions on how we got e by itself? What do we need to do to get the variable out of the exponent? We need to apply a logarithm specifically. The natural log of both sides. Because the natural log of e to the 2x plus 1 is going to reduce to 2x plus 1. And the natural log of 1 is 0. So this one actually does work out nicely. Now we just need to solve for x. First thing we can do in solving for x is 2. Subtract 1. Telling us 2x is negative 1. And divide by 2. Telling us x is equal to negative 1/2. Questions on number 5. Now we got this here. Now, if the natural log of 1 did not work out nicely, we would have left it. Number 6, we have 7 to the x is equal to 3. Our term with the variable in the exponent is already by itself. So we need to get the variable out. And we can do that by applying what? We wouldn't use the natural log. We'd use log base what? 7. We could use natural logs, but it would be a little bit easier to use log base 7. Is log base 7 of 7 to the x is what? X is equal to log base 7 of 3. And well, log base 7 of 3 is not a nice number. That's our answer. Questions on these first 6? Get ready for the next one. So we have 11 to the 6x plus 2 is equal to 38. So the first thing we can do is apply what? We want to get that log of what? 11. Log base 11 of 6x 11 to the 6x plus 2. On the other side, we have log base 11 of 38. Now our log base 11 of 11 to the 6x plus 2 is going to reduce to 6x plus 2. Is equal to log base 11 of 38. Now that we have the variable out of the exponent, we do need to solve for x, because here x is not by itself. So the next thing we need to do is what? Subtract 2 from both sides, because our 2 minus 2 would be 0, leaving us with 6x. Is equal to log base 11 of 38 minus 2. And lastly, we would which will tell us that this here is x is equal to log base 11 of 38 minus 2 all over 6. And that's it. Yes. Yes. You're welcome. Any questions on this here? We ready for the next one? For the next one we have the natural log of 3x plus 2 is equal to the natural log of 4x minus 5. We have two of the same logs that are equal to each other, yes? So if the logs are equal, it means what's inside has to be equal. But really what we did is we put both sides to the base of e, because e and our ln would cancel, e and our ln would cancel, leaving us with 3x plus 2 is equal to 4x minus 5. And at this point here, we just need to solve for the value of x. Well, the first thing we could do, we could minus 2 from both sides. We could add 5 to both sides. We could have subtracted 3x or subtracted 4x. We just need to pick one of them to do. So I decided to add 5 to both sides, which gives us 3x plus 7 is equal to 4x. Next thing we can do is subtract 3x from both sides. Minus x is equal to 7. Or 7 is equal to x. Questions on this here? We ready for the next one? Log of 12x minus 9 is equal to log of 3x. Since the logs are the same, what's inside has to be equal. 12x minus 9 is going to equal 3x. Now that we have this set up, we need to find the value of x. And the first thing we can do is what? Yeah, we can add 9 to both sides, which will tell us that 12x is equal to 3. Yes, then we can indeed subtract 3x, which tells us 9x is equal to 9. And lastly, we can divide both sides by 9, telling us that x is equal to 1. Any questions on number 9? We're good with these so far. Again, just like number 9, number 10, log base 2 of x squared minus x minus 6 is equal to log base 2 of negative x. Since the logs are the same, what's inside x squared minus x minus 6 is going to have to equal negative x if these are indeed going to be equal. Now, since we have an x squared term, we need to get this equal to 0. We can add x to both sides. And on our right-hand side, negative x plus x is 0. On the left-hand side, we'll have x squared, and our negative x plus x is 0. So we have x squared minus 6. Questions on how we got to this here? Now at this point here, we can graph it. So we can grab the graphing calculator, hit y equals, and type in x squared minus 6, and hit graph. And we do see that it crosses the x-axis at 2 points. But they do not look like nice points. They're between our integers. And we can look at the table, second graph. Well, the values of x that make the y value 0 are between negative 2 and negative 3, and 2 and 3. So we'll need to solve this here. Now, incidentally, because there is no middle term, we can use the square root method. And the square root method says that we get the x squared term by itself and our constant terms on the other side. So that will tell us that x squared is equal to 6. Now at this point, we're going to take the square root of both sides, telling us x is equal to plus or minus the square root of 6. And really we have two answers. We have that x is equal to the square root of 6, and x is equal to negative square root of 6. Now, if you do get more than one answer, it's going to be good to check them to make sure they work, because when we plug it back in for x, what's inside the logarithm cannot be negative or 0. So the values of these two here cannot be negative or 0. So if we plugged in the square root of 6, the value of this here cannot be negative or 0. And we could do this in a calculator. We can say, parentheses, second square root of 6 squared minus the square root of 6 minus 6 is negative square root of 6. Our other is negative square root of 6. Well, that's just negative square root of 6. And when we plugged it in, because both of these were negative, it tells us that x equals the square root of 6 will not work. It does not work because it gives us a negative number inside the logarithm. So we throw it out. Now we can check negative square root of 6. So we'd have negative square root of 6 squared minus negative square root of 6 minus 6. And again, we can check this in a calculator. And it gives us positive square root of 6. In our other case, negative square root of 6. Well, the negative and negative is going to make a positive, and it will be square root of 6. And since both of these, when simplified, plugging that value of x back in, give us a number that is not negative or 0, the only solution for this here is that x is equal to negative square root of 6. Questions on this here? Questions on this so far? We ready for the next one? Problem number 11, we want to solve this here. Now this time we started out as a logarithm, and we want to get rid of the log. So to do that, we put both sides to the base of 7. Because our 7 to the log base 7, these will cancel, telling us that 4x plus 9 is equal to 7 squared. Now is 7 squared a nice number? So we can reduce this, we can simplify it. Now we just need to solve for the value of x. The first thing we can do is subtract 9 from both sides, telling us that 4x is equal to 40. And lastly, we can divide both sides by 4, telling us x is equal to 10. Questions on number 11. Now, if we look at number 12, the natural log of 6x minus 2 is equal to 7 is the natural log by itself. Yeah. So we can put both sides to the base of what? We wouldn't use natural log. We'd use base e. Because the natural log's base, even though it's not written, is understood to be e. So e to the ln would cancel, leaving us with 6x minus 2 is equal to e to the 7. Now, is e to the 7th a nice number? No. E is irrational, and no matter how many times we multiply e by itself, it's still going to be an irrational number. So we're going to leave it as e to the 7th. Now we just need to solve for the value of x. And the next thing we can do is add 2 to both sides, telling us that 6x is equal to e to the 7th plus 2. And lastly, we would divide by 6. Telling us x is equal to e to the 7th plus 2 all over 6. Questions on this here? Well, very good. Log base 9 of 2x plus 7 equals 2. Well, here we can put both sides to the base of 9. Because we need logs to get variables out of exponents. We need bases to get variables out of logarithms. So our 9 to the log base 9 would simplify out, leaving us with 2x plus 7 is equal to 81. We could write it as 9 squared, but 9 squared is 81. Now we can solve for x, and the first thing we can do is minus 7 from both sides, because our 7 minus 7 is 0, telling us that 2x is equal to 74. And last but not least, we can divide both sides by 2, telling us x is equal to 37. Questions on number 13? Number 14, the natural log of 6x minus 4 is equal to 15 is the natural log by itself. What is with it? Well, the 6x is inside the log, yes? What is with the log? What is attached to it? Minus 4. We need to get the log by itself. We have to add 4. Because up to this point, there was nothing being added, subtracted, multiplied by our log. So we have to get it by itself. Doesn't matter what's inside the log. Anything outside the log has to be moved to the other side. So we'd add 4. Now is the log by itself? Yes. And we would put both sides to the base of e. Because e and our ln would cancel, leaving us with 6x is equal to e to the 19th. Anytime we have e as the base, it's going to stay till the end. We're not going to need to plug it into the calculator. Now at this point, we're going to divide both sides by 6. Telling us x is equal to e to the 19th over 6. That's it. Questions on this here? We ready for the next one? Now our next set, we can't have 2 logs being added together and just move straight to solving. But if I do have 2 logs being added together, I can rewrite this as a single log with what's inside being multiplied together. Because I need this as a single logarithm for us to be able to simplify. Because once we have it as a single log, we can put both sides to the base of what? 2. And we use 2 because the logarithm's base is 2. So 2 to the log base 2 would cancel, leaving us with x plus 4 times x plus 1 is equal to 2 to the 2nd power, 2 squared, which is 4. Now at this point here, we can distribute. X times x is going to be x squared. X times 1 is going to be plus x. 4 times x is going to be plus 4x. And 4 times 1 is going to be plus 4. Now at this point here, we'll need to combine like terms. So x squared plus 5x plus 4 is equal to 4. Now since we have an x squared term, it might be helpful to get this equal to 0. Yes. So we subtract 4 from both sides, giving us x squared plus 5x is equal to 0, because our 4 minus 4 is 0, 4 minus 4 is 0. So what we're left with is x squared plus 5x. Questions on this here? Now at this point we can graph it, factor it, or use the quadratic formula. Any of those would work. So we can type in x squared plus 5x and hit graph. And we do see, unlike the last one, this does cross at 2 nice points. And our table says that it crosses at -5 and 0. Because we're looking for values of x that make the y value be 0. Now I will say anytime we have 2 solutions, you do need to check to make sure that both of them work. And if one of them doesn't, we're going to mark it out. Now our 2 places that we can't have 0 or negatives is 4x plus 1 and x plus 1. Now the first value we can try is -5. Well, -5 plus 4 is -1. Well, really we can mark it out at this point, because if one of them is negative or 0, it's not going to work. Now we can check the other one. -5 plus 1 is -4, so it really doesn't work. Now we can check the other value of x. So 0 plus 4 is 4. 0 plus 1 is 1. When we plugged in 0, we got 4 and 1. Neither one of those is negative or 0, so our value of x that works for this here is x is equal to 0. That's it. Questions on this here? Be ready for the next one. We have log base 2 of x plus log base 2 of x minus 2. Since we have 2 logs being added together, we could rewrite it as a single log with what's inside being multiplied together. So it tells us that this will be rewritten as log base 2 of x times x minus 2 is equal to 3. Now at this point we can put both sides to the base of 2. Now our 2 to the log base 2 will cancel, leaving us with x times x minus 2 is equal to 2 to the third, or 8. Now on the left-hand side, we do need to distribute. X times x is going to be x squared. X times -2 is -2x is equal to 8. At this point here, it would be helpful to get this equation equal to 0. So we'd subtract 8 from both sides. Telling us that x squared minus 2x minus 8 is indeed equal to 0. Questions on how we got to this point here? Now at this point here, we could graph this. We could factor it, quadratic formula. I'm going to go on and graph it. X squared minus 2x minus 8, graph. And again, we get 2 nice locations, 2 nice spots that it crosses. Second table. Our 2 values of x's that make the value of y be 0 are -2 and 4. And especially on the test, if two places, or not two places, if we do get two values of x, it will be good to check them both, just to make sure one of those does not make something inside the logarithm be 0 or negative. Now for our x, because log base 2 of x, if I just replace our x with -2, well, we just end up with -2. So we can say that -2 is not going to be a solution. We can check the other one, -2 minus 2 is -4. So that kind of emphasizes the fact that -2 is not the correct solution for this. Our other one is 4. And for our log base 2 of x, or just x, it would give us 4. For our other one, 4 minus 2 is 2. So for number 16, the only solution that does work is x is equal to 4. And again, on these here, I do want both solutions. Even though the one doesn't work, I do want you to give me both and mark out the one that doesn't work. Questions on this here? We're going to finish this up tomorrow.